Hi guys, welcome back. Today we're not going to do any new information at all. I just want to take a day to go back over some of the semester one things that you should know very well. Since we're not having a midterm exam, that's usually my opportunity to review everything and put it all together and help you memorize. So I'm going to do just like a quick review right now. All right, so print out this paper. It's on Canvas. Make sure you print that out and save it. These are your justifications when we get to AP exam time, okay? Most of this I'm sure you know cold. I'm sure you know if f of x is increasing, that means you write automatically f prime positive and you think first derivative sign chart, okay? F of x decreasing, same thing. The derivative is negative. You write that on the paper. I'm talking about for free response questions on the AP exam. If it says f of x decreasing or anything decreasing, you write that thing's derivative is negative because that's a point on the AP exam. And then your goal is to do this. Now, this, the sign chart, is not graded. You don't get any points for that, but that's what you do, okay? You have to write these things. All right, so I'm sure you know concave up and concave down and all that stuff. So let's go to where it says maximum and minimum. Okay, so I want you to compare a maximum, like a local max, or a maximum if they ask for a max or a min and they don't give you a closed interval, okay? If they just say find the maximum versus this guy, a maximum but there's a closed window. Often this is a word problem and it'll be a closed window like time. They'll say that, I don't know, snow is falling and it starts at 8 a.m. and ends at 12. So that's a closed window, okay? So a max on an open interval versus a max on a closed interval. A maximum on an open interval is what you typically do, first derivative sign chart. But if it's a max on a closed interval, that's when you have to check your endpoints and you do a table to check those endpoints. And in that table, you'll put the -1 and the 7, and you'll do this part, set the derivative equal to 0 to find any critical points, okay? So I want you to study the difference between a maximum on an open interval and a maximum on a closed interval. If it's an open interval, you do a first derivative sign chart. If it's a closed interval, you do a t-chart. Remember to check endpoints. And that is actually called the extreme value theorem, by the way. Now, to help you remember why it's different for a closed interval, I'm going to reteach that real quick. If I have a graph with arrows, something like this, and I ask for a maximum, well, it would be just this guy right here. Well, that's not very close. There you go. That would be my maximum, right? But that's actually a relative max because in truth, there's no maximum if this thing goes up forever. Your actual total overall maximum or absolute maximum, there isn't one because that's an arrow. It goes on forever. So when we ask for a maximum, right now we're talking about a local maximum or a relative maximum. However, if I change this graph and make it a closed interval, okay, closed interval, which means solid endpoints. Okay, now my maximum could be the critical point right here, or it could be the endpoint. So that's why when we have a closed interval, we have to do a t-chart to compare the critical point to the end point, because the end point could end up being your maximum. Okay? Okay, now I want to skip ahead to motion along a line. It could be the x-axis or the y-axis or just along any line, okay? When we talk about motion of a particle. And we will be teaching more on this next semester. So there's actually two things in here that you haven't done yet. These two things, this is second semester info. So we'll be reviewing all of this again, okay? So motion of a particle. Typically they give you the position, and position often used as an x of t, okay? The derivative of position is velocity, okay? Velocity is the derivative, first derivative, that's velocity. And hopefully remember the second derivative is acceleration, okay? So the derivative of velocity is acceleration. All right, now, this is all supposed to be review. Notice that all of these justifications have velocity in them. If they say, when is a particle moving to the right, you write velocity positive. When is a particle moving left? Velocity negative. When is the particle stopped? Velocity is 0. If they say, when does the particle change directions? Velocity is 0, but you have to state changes signs, okay? And speed is the absolute value of velocity. Anything where you're concerned about the sign, whether it's positive or negative, you're going to use a sign chart. All right, now let me make up an example. Let's say this is a velocity graph, okay? This is the velocity of a particle, and let's say the velocity goes like this, I don't know, okay? Let's say the velocity here is maybe 4, and maybe the velocity here is like -3, okay? So, if this is a particle moving along the x-axis, all right, then when velocity is positive, velocity positive means particle moving to the right. So the particle would be moving to the right for all of this. That's particle moving to the right because the velocity is positive. It is above 0, okay? So the particle's moving to the right for all of this. The particle's moving to the left for all of this, okay? When does the particle turn around? Right here, because it changed from positive to negative. When is the particle stopped? That's here, here, and here because velocity is 0. Okay, so hopefully that makes sense. Again, moving right would be all of this. Moving left is all of this. All right, now let's talk about speed. Speed is the absolute value of velocity. So right here, the velocity is 4, and the speed is also 4. Here, the velocity is -3, but the speed is 3. So the common question they'll ask is, when is the particle speeding up or slowing down? Speeding up, well, here it's velocity or speed of 0, and here is a speed of 4, so this is clearly speeding up. However, this is 0. This right here is a speed of 3. It might be velocity -3, but this is a speed of 3. So in this region right here, we're also speeding up because our speed went from 0 to 3. 0 to 3. Okay? So speeding up is kind of like going away from 0. Speeding up is going away from the x-axis, here and here. Those are speeding up, okay? Now, the technical definition of speed, it's true that speed is the absolute value of velocity, and that's what I think when I'm trying to interpret it graphically like we just did. But if instead of the graph, if they give us the equation, then the formal definition of speeding up is when, or speed increasing, is when velocity and acceleration have the same sign. Okay? That's what speeding up would be. All right, so that's the formal definition. And again, we're going to do this again later on in the year. But so let's talk about why this is what it is. Okay? First, we're going to approach velocity on this graph. All right, so let's go through our graph. And let's look at what is the sign of velocity. Remember, all of this is a positive velocity. All of this is a negative velocity. So right here, velocity is positive. And here, velocity is positive. On the bottom, this is velocity negative. And this is velocity negative. Okay, now let's do the same thing, but let's talk about the acceleration on that graph. Acceleration is the derivative of velocity. So if it's the derivative, we're going to look at slope. Okay, so now we're looking at acceleration, which is the slope of that graph. Okay, well in the first region right here, that's a slope that's positive. In the next region, this is a slope that's negative. This is also a slope that's negative. And last section, this is a slope that's positive. Okay, so put it all together. We said speeding up is going away from 0. This was speeding up, and this is speeding up. Notice the signs. The signs there are the same. So speeding up, if you can look at the graph, speeding up is going away from 0. If you can't look at the graph, it's when velocity and acceleration have the same sign. Okay, so let's go back to that sheet of justifications. So speed, okay? Speed, this is my go-to because that often works and I can think of it that way when I'm dealing with a graph. But if that doesn't work because you don't have the graph, then formally, speeding up, you should add this to your notes. Speeding up or increasing speed is when velocity and acceleration have same sign. Okay? I can't quite fit it all in there, but you should also add slowing down. Slowing down would be velocity and acceleration have opposite signs. Okay? And you have to write that on a free response question. Okay? All right. Next concept that I want to review with you is continuity. Okay, continuity, just to remind you of it, a function is continuous, and this is also often a free response question. If they want you to show that something's continuous, there's a 3-part definition, okay? You have to say the limit from the left, which would be like this. Remember, limits are the height you are approaching. The height you are approaching, regardless of whether or not you get there. So this would be the limit from the left, okay? It has an open circle. Then that has to equal the limit from the right. That would be this. They're in the same spot. That means the limit exists, but it's still not continuous. So to make it continuous, the left-hand limit and the right-hand limit have to also equal the value of the function, which means there's a solid point there. Okay? So that's what the definition of continuity is, just to make you think about it again and try to keep it in your brain. No big deal. All right, now let's talk about rate of change. This one's huge. Okay, rate of change is a gigantic thing. Rate of change is basically the entire first semester, the whole concept, okay? Average rate of change versus just the word rate of change. They don't have to say instantaneous, okay? If it just says rate, that means you're finding the freaking derivative, okay? You got to know rate means get derivative. Done. However, just be warned, if it says average rate of change, that's an estimated derivative, algebra 1 slope, okay? So try to memorize that. All right, we're just trying to put everything together that we've learned so far this year. Mostly I'm focusing on the things I think you may have forgotten, just so you look at it again, okay? And we'll be doing all of this again when we study for the AP exam. Okay, next, your theorems. The mean value theorem. And they often use, they'll say the name mean value theorem, so you're going to have to know what that means. You also often have to use the mean value theorem, and you have to state it on a free response question, and you are allowed to just say MVT. All right, the mean value theorem, let's look at it in real life first. If I take a trip and my average speed for that trip is 65 miles per hour, then I definitely had to actually hit 65 at some point. I probably went less than that and more than that, but if it averaged 65, then I definitely also hit 65. Okay, that's that in the real world. If you have to do something with it and you're solving a problem, it basically means your estimated derivative, average speed, has to equal your actual derivative, what's on my speedometer, at any given time. Okay, I think for mean value theorem, I always just think of it as estimated derivative equals actual derivative. Okay, so when you do that, if you do this type of problem, they might give you, and I give you one on the worksheet today, they'll give you an equation and a closed interval. If they say, for what values does the mean value theorem apply, you do the actual derivative and set it equal to the estimated derivative, f of 3 minus f of 1 all over 3 minus 1, and solve. Okay? Okay, intermediate value theorem. Oh wait, time out. I need to go back to the mean value theorem. There's something else I wanted to say about that. When will you have to state MVT, mean value theorem, as a reason for a free response question? Often they give you a table problem. Pretty much every exam has a table problem. And we'll do a lot more with this as we progress through the year. But something that you've already done, if I give you a table and I say, what is f prime of, say, 3? Okay, this was way early in the beginning of the year. F prime of 3, to find that, We estimate it. We can't get the actual derivative. This is estimated, but we use the two numbers surrounding it, and we do the algebra 1 slope. So it would be 5 minus negative 7 over 4 minus 2, okay? If they ask for the derivative or the rate of change at 3, we use the 2 points surrounding it. Hopefully you remember that. If ever you do that, anytime you estimate a derivative from a table, that's actually MVT. You're saying that this estimated derivative I get has to be equal to the actual derivative at some point. So if they ask you to justify when you do the derivative, if they ask you to justify, it's mean value theorem that's letting you do that. Okay, intermediate value theorem, IVT, and you're allowed to state IVT. This is typically not a free response question, but it would come up as a multiple choice question, and it'll have like only part 1 is true, part 1, 2, and 3 are true, and a bunch of true false things, okay? And I'm not going to stress this too much right now because I'll review it hard right before your exam again. But anyway, intermediate value theorem is actually really easy. Okay, let's look at the real world thing first. If the temperature in my room goes from 70 degrees to 90 degrees, then clearly it had to hit all the temperatures in between. It doesn't just jump from 70 to 90, okay? So, and it happened from 8 a.m. to 11 a.m., then somewhere between 8 and 11, it hit like 73 degrees for sure. That's all it means. So what they'll do for this is maybe give you 2 points, 2 random points, okay? Let's say they give you that f of 1 is 9, and maybe they give you that f of 7 is 14. And then they'll say like a true false. It's definitely true that at some point there's a value such that maybe f of 3 equals 11. Can that be true? Well, is this 3 in between the 1 and the 7? Yes. And is 11 between 9 and 14? Okay, it's just kind of a common sense. Anyway, I'll do more about that in the future. Actually, let me do a little bit more right now. They won't say f of 3 is 11. What they'll say is, let me erase that. They'll say there is some value of c such that its height is 11, and that value must occur somewhere between 1 and 7. Okay? It's possible it could be at 3, but it could be at any number. All right, moving on. Extreme value theorem, that's every time you do a t-chart to find a max-min. If you need a max-min on a closed interval, that t-chart that you do, that's actually extreme value theorem. So if they ask you to justify, you just say by EVT. But usually this one's justified just by showing your work and showing that you check the endpoints. Okay, so obviously that's not everything we learned semester 1, but that's just some of the stuff that I need to really drill and kill and make you memorize. And the more we practice memorizing it and the more times per year that I go over it, the better chance you have of retaining it for the AP exam. None of this is new. Make sure you keep this sheet of justifications. Have a worksheet for you to practice some of it. I kept the worksheet real basic. I really just want you to memorize these justifications, stare at this sheet and try to memorize all of it, and then go and try to do your worksheet today, which is just a little quiz of these justifications, these concepts, like the difference between a max on an open interval and the max on a closed interval. Okay? So good luck, guys. Let me know if you need any help. Bye.